Now see some question based on the magnetism. Question number 1, it is based on the assertion region. The assertion given as the basic difference between an electric and magnetic lines of forces is that former is discontinuous and the latter is continuous, and the region is no electric lines of forces exist inside a charged body, but magnetic lines of forces do exist inside a magnet. So if we are looking the assertion and region, so magnetic lines of forces is always making a closed curve, so those lines is always your continuous, while electric lines of forces never making a closed curve. These are the lines due to the charged particle. So we can say electric lines of forces due to charged particle is discontinuous, but magnetic lines of forces are continuous. So assertion A is the correct. And in the region we can say, in the region it is mentioned no electric lines of forces exist inside a charged body. So as we know, inside a charged body, any charged conductor, inside a conductor there is no electric field, so that's why there is no electric lines of forces, but outside the electric field or outside the charged body electric lines of forces are present. But in case of magnetic lines of forces will present inside as well as outside. So both options are in a region as well as assertion, both are correct, and assertion this explained by the region. So option number 1 is the correct option. So question number 1, so we can say electric lines of forces due to charged particles never makes closed curve, and there is no electric field lines inside a charged body, inside a charged conductor, while magnetic field lines always makes closed curve. So our correct option is your option number 1. So answer 1 is the correct answer. Question number 2, assertion is at neutral points a compass needle point out in any arbitrary direction. Reason, magnetic field of earth is balanced by field due to magnet at the neutral points. So when we are talking about the assertion, as the neutral point means there is no net magnetic field, so at the no net magnetic field, so there is no defined direction of the magnetic needle. So magnetic needle can stay at any position, so there is no fixed proper direction. The assertion A is the correct. And reason is the neutral point is the point where net magnetic field is 0. The net magnetic field 0 means magnetic field produced by the magnet as well as magnetic field due to earth, both are equal and opposite. So that's why the net field is 0. So that point is called neutral point. So reason explain the assertion. So our option number 1 is the correct answer. The question number 3 is also based on assertion region. So assertion A is when a magnet is oriented at 180 degree with the field direction, it is in a state of unstable equilibrium, and the reason is that it possesses maximum potential energy. So now see, what is the meaning of this statement? So this is let the magnetic field in this direction, and this is the magnet. The magnet is oriented 180 degree with the magnetic field direction, means magnetic moment of the magnet is in this direction. As we know, torque on a magnet is given as m cross b, while potential energy of the magnet is written as m dot b. So modulus of torque is mb sin theta, while modulus of potential energy or minus mb cos theta. Now as theta is here 180 degree, so when theta is your 180 degree, so torque is 0. So torque 0 means torque is 0, that is the equilibrium. It is the condition of equilibrium, and u is equal to here m into b. This is the maximum potential energy. So whenever potential energy is of a body is maximum and it is in equilibrium at this position, so that equilibrium will be always unstable equilibrium. So at an unstable equilibrium the body must have maximum potential energy. So our assertion is the correct, and region is correctly explain the assertion. So our option number 1 is the correct option. Question number 4. Select the correct statement. A option given, the direction of magnetic moment is south pole to north pole for a bar magnet. Second option, magnetic flux is scalar. Third option, torque on a magnet is maximum when magnet is perpendicular to the direction of external magnetic field. And the fourth option, the time period of vertical motion is independent of length and thread. So the first option, your A and B both statement correct. Second option, your B and C both statement are correct. Third option A, B, C, and fourth is all C. First of all, when we are talking about magnetic moment, this is the magnet south pole and north pole. South pole is pole strength here normally negative, and north pole strength here positive. So magnetic moment direction is always from south to north pole. This is the correct one. So A is correct. In the B statement they are saying magnetic flux is scalar. This is also correct. B also correct. And torque is the maximum. Torque expression as we know, that is your mb sin theta. So theta is the maximum, torque will be maximum when theta is 90 degree. It means magnetic moment and magnetic field are mutually perpendicular. So our option C is also correct. And time period of a vibration magnetometer is given as 2 pi under root I by mb. I is the moment of inertia, m is the magnetic moment of the magnet, and b is the magnetic field. So it is independent of the length of thread. So D option is also correct. So all the 4 statement and correct. So option number 4 is the correct answer. Question number 5. The resulting intensity of two similar bar magnets at some point at constant distance from their centers can be. There are 4 options given. First 0, second your finite, third your infinity, fourth is always unity. So first is correct, first and second may be correct, third 1, 2 and 3 may be correct, and the fourth, second and fourth may be correct. So whenever if we are looking the resultant magnetic field, the resultant magnetic field B is equal to your B1 square plus B2 square plus 2b1 b2 cos theta. So this is the radiated magnetic field due to bar magnet. Since similar magnet, for similar magnets, so B1 is equal to B2 is equal to B naught. So B is equal to, we can say, 2B naught square 1 plus cos theta. The B value can have 0 value as well as B value have some finite value. So 1 and 2 option may be correct, and that 1 and 2 option given by the option number 2. So second is the correct answer. Question number 6. Two similar magnets A and B having the same magnetic moment A are taken. A is cut along its equatorial line, B cut along its axial line. All the four pieces have: first, the same pole strength; second, the same magnetic moment; third is the magnetic moment half; fourth is the pole strength or half. So in the first option, either 1 or 2 correct, second option 2 or 3 correct, third option 3rd and 4th correct, and the fourth option 1 and 3rd is correct. See, as it is given, there are two similar magnets. Let this have pole strength, your pole magnetic moment, your M. This is also same magnetic moment M. So what is the meaning of magnetic moment? This is pole strength. M is your M into L. Same thing here also, M into L. But one of the magnet is cut like this, equatorial. So we will have two magnets, but each will have same pole strength. Each will have same pole strength, but their magnetic moment will be different. M dash will be your now M by 2, and here this cut like this. Then we will have, this is the magnet. Here magnetic moment your M by 2 and M by 2 this. The magnetic moment, magnetic pole strength will your reduces. But the thing is that M by 2 into L. This is your M by 2, M dash. So what is the same thing? Their magnetic moment will be same, but here pole strength will be same, but here pole strength will be reduced. So out of 4 options, in the option number 2, the same magnetic moment. So same magnetic moment, this is correct one. And in the third option they have given magnetic moment half. Magnetic moment half. So now earlier magnetic moment was M, now the magnetic moment become your half. The second and third statements are correct, and the option number 2 indicate the second and third statement. So option number 2 is the correct option. Question number 7. A wire whose magnetic moment is M is bent into an arc of a circle which subtends an angle theta at the center. Arrange the new magnetic moment for this. For theta 180, for theta 120, for theta 90, and for theta 60 degree. So let's see here, this is your wire of length L. So right now magnetic moment here M into L. L is the length. In the A option, it is your now 180 degree. In the A option, the wire has been bent like that. This is the wire, it has been bent like this. So the wire has been bent in the form of a semicircle. First option, this is the angle theta. So still now L, total length your L, total length L, L is equal to pi r. Now the magnetic moment your M1, M1 is equal to your M, and this is your 2R. 2R means here M, 2R, 2L by pi. So this is your M1 is your M into L, 2M by pi. This is the magnetic moment of the first part. Similarly, in second case, it has been made 120 degree. 120 degree means it bend like this. It bend like this. This angle your 120 degree. So now see here, this is the distance between these two. Now L is equal to here 2 pi by 3 into new radius r dash. So magnetic moment M2, M, this is your r dash, this angle 60. So this will be your r dash sin 60. This is also r dash sin 60. So 2r dash sin 60. So sin 60 your root 3 by 2. The root 3m, r dash your 3l by 3 by 2 pi into L, and m into L is your capital M. So 3 root 3 by 2 pi into capital M. This is the B and C part. In the C part, this is your length your 90 degree. So this is total length your L. So this is your L by 2. This is also L by 2. So this is your magnetic moment. M dash is equal to your or M3. M3 or M into this length. This length is equal to your root over L square by 4, L square by 4, L square by 2. So M by root 2. And the fourth case, when the angle subtended by this is 60 degree. In the D option, when this angle your 60 degree, this is 60, this is your 30 degree. So length L. L is equal to your r into pi by 3, new radius r double dash. So this is your r double dash. So magnetic moment M4, that your M, this is your r dash sin 30, the 2r double dash sin 30 your r dash, the M, r double dash your 3l by pi, so 3 by pi into capital M. So this is your M4. Now from here we can conclude. So in the first, this value are less than M. This is your M2 your 3 root 3. 3 root 3 is around 5.1 by this is also M less than. This is also less than M. And this is also less than M. Now we can rearrange, and from rearranging we can get the option number 2 is the correct answer. Now come to the question number 8. This is based on the match the following. In the list 1, first is given magnetic flux, second is magnetic field or magnetic induction, third is magnetic intensity, and the fourth is magnetic moment. In the list 2, first is given L square A, second ML square T minus 2A minus 1, third is MT minus 2A minus 1, fourth is your L minus 1A. See here. In the column 1, first is given as magnetic flux. Magnetic flux phi. That phi is your B into A. See, magnetic field we can get the dimension of phi. Dimension of phi is the dimension of magnetic field, and dimension of magnetic field can be written as dimension of F by IL into dimension of area. Dimension of F ml t minus 2, current your dimension A L, this your L square. So that will come your m L square t minus 2 A minus 1. This is the dimension of your flux. So dimension of flux in the given option, it matches with the option number F ml square t minus 2 A minus 1. Similarly, dimension of B was our, and dimension of B second, magnetic induction. Magnetic induction dimension of B is your F by IL. F by IL is your m t minus 2 A minus 1. This is dimension of this. So first, in the first option A matches with the F. Similarly, in the second, B matches m t minus 2 A minus 1, that is G. Similarly, we can see for the third is your magnetic intensity H. Magnetic intensity H. So that is your written as H is equal to your B by mu. From that we can get, so after solving we can get dimension of H is equal to your L minus 1 A minus A, and D is your, next is your our magnetic moment M. Magnetic moment M is equal to I into S. I is the current. So current your A, S is your area, A L square. The area square means E. So for C option is your, H, and for D option is your E. So the correct option your answer number 1. Question number 9. Which of the following is the main source of magnetism in a bar magnet? In the bar magnet, there are 4 options given. First, spinning of electron. Second, spinning of atoms. Third is the orbital motion of electron. Fourth is the polarization of atom. So correct option is the spinning of electrons. Those spinning of electron act just like a current carrying loop, and that current carrying loop produces magnetic field. So correct option your option number 1 is the correct answer. The question number 10, to identify the correct relation among the following quantities. First is B is equal to mu naught into mu r h in a medium, and B option your B is equal to mu naught h plus I in a medium where the letters have their usual meanings. Then the first option A is correct, the second B is correct, and third both A and B are correct, and the fourth A is correct and B is wrong. So it is given as B is equal to your mu naught mu r into h, and another relation given as B is equal to your mu naught h plus I. I is nothing, it is the induced magnetic field due to magnetization, and mu naught is the magnetic permeability of free space, mu r magnetic permeability of the medium, h is the magnetic intensity. So both option and both statements are correct. So our correct expression is the expression 3, which indicate both of the statement are correct. Question number 11. Find the resultant magnetic moment for the following arrangement. First is given root 2 plus 1 m, second is root 2 minus 1 m, third is root 2 m, fourth is M. So in the question there are 3 magnets are given and their magnetic moments are arranged like that, M, M and M. And this angle here 45 degrees. So first we can resolve all this. So if we are resolving here, M cos 45, M by root 2. This is also M by root 2. Here M by root 2 and M by root 2, so root 2M. Along with this 1M. So these two will cancel. Resultant magnetic moment Mr will be your root 2M plus M. So correct answer your root 2 plus 1 into M. This is the resultant magnetic moment. So option number 1 is the correct option. So answer 1 is the correct answer. Question number 12. Two identical magnets, each of magnetic moment M, are placed as shown in the figure. The net magnetic moment of the combination. One option is M, second option is M root 3, third option M by root 3, fourth option 2M. Here in the diagram there are two magnets are given like this. One is your north-south like this and another is a magnet like this. Here also north-south like this. And the angle between this is given here 60 degree. It means there are two magnets, their magnetic moment are making an angle 60 degree, each having magnetic moment your M. So resultant is equal to your M square plus M square plus 2M square cos 60. Cos 60 1 by 2, it become your root 3 into M. So correct option is your option number 2 is the correct answer. Question number 13. Half of the bar magnet of magnetic moment M is bent in the form of a semicircle. Its new magnetic moment become. The first option M by pi, second option M by 2 pi 2 plus M, third option 2M by pi and the fourth option M by pi 2 plus pi. See, in the question here, this is the initial condition. Given this length is your L and M is the magnetic moment, magnetic pole strength. So M into L this. Now it bent in the form of a semicircle, half of that, like this. In this manner it has been bent. So this is your L by 2 and this is your 2R. So remaining length L by 2 will be your pi into R. So radius is your L by 2 pi. So one magnetic moment M resultant in M1 plus M2. M1 is here M into L by 2 plus M2 your M and into 2R. Into 2R is your L by 2 pi. So M into L is your capital M. So capital M 1 by 2 plus 1 by pi. So this is the resultant magnetic moment, and if we are taking a 2 pi as a common, M by 2 pi, so then it will be your pi plus 2. This is the resultant magnetic moment. So our correct option is your option number 2. So answer 2 is the correct answer.